Rewrite the following absolute value inequality so that it's in this form: x minus a greater than b. Then graph it and write it in all the different ways. Well, first thing is, let's come over here. Could actually end up being this, but we'll just have to see how it goes. 3 minus 2/3 x. Okay, notice there's no coefficient in front of x, but there is here. It's 2/3. So we need to factor out a 2/3 inside of the absolute value. If I factor out a 2/3, this would be an x and a minus. And by the way, I just realized that this is positive x here. So let me amend this slightly. Instead of factoring out positive 2/3, let's factor out negative 2/3. Okay. And so let's just check. What would if I factor negative 2/3 out of here? What would that be? That would be negative 9/2. Now let's check that. How do you check what that is? Well, when you distribute the negative 2/3 times negative 9/2, well, the 2's are going to cancel. The negatives cancel to be a positive, and 9 divided by 3 is 3, and we get 3. So if I distribute this to here and multiply those, I recover the 3. So that kind of checks that I've factored things correctly. So this is my little check. Okay, so we've factored out a negative 2/3, and what's the advantage of that? By the way, I just noticed that that needs to be a positive, because if I factor the negative out of here, negative 2/3, then this is left as a positive, and that's actually what I want. I just wrote the wrong thing. First off is one absolute value property is you can rewrite this like this, and you can put this in absolute values, and I can rewrite it as x minus 9/2. So I have 6 is less than 2/3, absolute value of x minus 9/2, and I'm almost done. Multiply both sides by 3, divide both sides by 2, and I will get 3 times 6 is 18, divided by 2 is 9, so I get 9 is less than absolute value of x minus 9/2, and that's what we set out to do. Now, the form that it said to write it in was just to flip it around the other way, but it is the same thing. And we learned how to graph this graphically. When you have x minus a number is greater than a number, what we have is our center is at 9/2, and we need to add and subtract 9 to that. Now I did that on the side. I'm not going to go into doing all the fractions. You can figure that out. You're on the top side, it's 27/2. So what I did here was I added 9. This distance, let me do it this way. This distance here is 9. And this distance here is 9. You can think of it as just a distance of 9 without sign. And this value over here is negative 9/2. And yeah. And so this is the center, and we want the distance from x to negative 9/2 to be greater than 9. So we want x to be farther away from 9/2 than 9 units. So if x is here, its distance from here to 9/2 is greater than 9. So when it's greater than, we want to shade everything on the outside. Shade everything on the outside. And we don't include the boundaries because it's greater than. We don't want it equal to. Okay, again, I'm going through these kind of fast because they are repeats of what we did in class. So we did a slower explanation in class. So I'm just quickly running through this. there's two ways to do this, by the way, says, oh yeah, I'm sorry. Actually, I wanted to do one more thing. It says write using set notation with inequalities and interval notation. So our book would say the set of all x such that x is less than -9/2 or x is greater than 27/2. And I'm a fan of writing the inequality the other way. Since the x's are to the right, I like to write it this way. Either one is fine. Now, the preferred notation that you will use in the future is interval notation. Everything from -infinity up to -9/2, parentheses, union, 27/2 to infinity. This is the notation you will see in pre-calc honors and AP Calculus. And this is the notation that's in our algebra book, and you will see it in the future if you become a math major. And this is the graph. All right. Now, solve the following. Graph your solution set and also write your answer in set notation. Let's do the graphical approach here. The distance from x to 1, because there's a minus here, remember there's a minus, so my center is 1. The distance from x to 1 is at least 1 and at most 3. I'll do this in green. So here's 1. And I'm going to go 1 unit away. That's 2 and 0. And now I'm going to go 3 units away. 3 units away from the center, 1. 1, 2, 3. So it goes 3 units up to 2, 3, 4. That's 3 units away. 1, 2, 3. Now I go 3 units to the left. And that would be -2. Okay. This inequality is saying the distance x is from 1 is at least 1. So x needs to be at least 1 unit from 1, which means it can be 1 unit away or more. But the most it can be away is 3. The distance x is from 1 is at least 1 unit and at most 3 units. So it can live anywhere inside of here. And that's actually the graph of this inequality. Now, what about this other one over here? I'll do it in blue. Let's just solve this quickly. I'll save you the algebra that I know you can do. If you solve this, you're going to get 6 is less than or equal to x, or x is greater than 3. So let's graph that. X is greater than 6, or x is greater than or equal to 6, or x is greater than 3. So what would that look like? I'll graph it in green. Everything greater than 3 would be this. Everything greater than or equal to 6 would be this. Now this is an or, so we want to keep what's in each of the green sets, if it's in one set or the other. Well, this set includes everything that's in this set, so the answer is it's x greater than 3. It simplifies to that. So our graph here is everything greater than 3. All right. This and means we want everything that is in this red set and simultaneously this red set. Well, you can graph them over the top of each other. You can just do the analysis right away, but just visually I can do -2 to 0. And 2 to 4. And then this set is everything from 3. I'll graph it over the top of this. Everything from 3 up. Now, because this is an and between these two, there's a big and in between. We want what's in the left side set and the right side set simultaneously. And the only overlap is between these two, where the two sets overlap. And it's everything from 3 to 4. It includes 4, but does not include 3. In interval notation, that would be 3 to 4 bracket.